The best way to learn about the Flow programming language is to take a look at the test cases that are included with the repo. So let's go ahead and do that right now. The first command that we're going to take a look at here is the test add command. And basically what this allows you to do is you pass in a couple of integers and it adds them together, and then it generates a string basically saying A plus B equals C. So we have a couple of types of operations here. The first is a primitive. Basically, primitives are functions that are included, base level functions that are included with the language. We also have a couple of constants here. Both are of type string. The one we have a plus sign and we have an equal sign. And then here we have what is called a local, which is basically just more flow code, just encapsulated inside of its own block of code. It'd be the equivalent of between the curly braces in a lot of textual programming languages. And then inside the local, we just have a whole bunch of add primitives, plus primitives. And the plus primitive basically will take any types, but if both types are numeric, it will actually numerically add those numbers together. If one or more of them are not numeric, then it will just add them together as strings. So the net result is it will produce a string that basically says A plus B equals C. So we've introduced a number of different types of operations here. Let's take a look at the next command in our examples or in our test cases list here. That is the test command. So each of these is a new bound command, and one of the operations that the Flow language supports in commands is to call another command. So here we're actually going to call the command that we just looked at, the test add command, and we're going to pass in a single value, but we're going to pass it into both nodes. And the result should be a similar string where it's basically A plus A equals 2A. Okay, moving on, the next command we're going to take a look at is the test conditionals command, and this basically will highlight the case structure and the match primitives. Basically, what this allows you to do is perform if-then-else type statements. Basically, in this case, you're passing in a Boolean, and if that Boolean is true, we're going to go to the next case. And if it's not true, we'll pass out the number 1. The next case, of course, simply passes out the number 2. So if you pass in a true, it'll pass out 2, and if you pass in false, it will pass out the 1. Now, the next command we're going to take a look at here is test lists, and this demonstrates another interesting capability of the Flow languages, with regards to nodes. So nodes can have modes, and one of the modes is list. And basically what that does is it will take an array of values, and it will iterate the operation for each member in the array. So in this case, we're going to pass in an array of presumably numbers, and then we'll add 1 to each of them, and then we'll output a list of numbers. So basically, if you pass in 1, 2, 3, it will return 2, 3, 4. The next test case is the test loop command. And this basically demonstrates the other type of mode that you can add to a node, which is to loop over an operation. And basically it will pass out a value, and these little arrows indicate that it will take the return value of an iteration and feed that in to the input for the next iteration of the loop. And it will continue that process for the duration of the loop. In this case, we're actually passing out a list as well. And so for each iteration of the loop, this will add an additional member to the array that is being returned on that right-hand node right there. Taking a look inside the local, we can see that hopefully you passed in a number and that the number was less than 4. Otherwise, this loop will run forever. Basically, this will add 1 to the value and test to see if it is 3. And if it is, then it will finish this case. That's one of the options you can have in terms of a match, is to fail or terminate, or in this case, finish. So the net result is it will pass out a 4 on the left-hand side, and on the right-hand side, let's say you passed in 1, it will pass out 2, 3, 4 on the right-hand side. The next command in our list here is the test speed command. And the primary function of this, as the name implies, is to test the speed of the flow language interpreter that it's running in. So we are currently here we're on the newbound command editor, and newbound commands can be written in Java, in Python, in Flow, and in Rust. We'll get to that in a little bit. But in any case, if you're running a newbound command in the newbound environment, and the command's written in Flow, that flow will be executed in the Java interpreter. So we also have the ability to add flow behaviors to the front end through the 3D editor. These behaviors are also available through the traditional HTML, CSS, and JavaScript editors. In any case, we have a JavaScript interpreter, we have a Java interpreter, we also have a Python interpreter that was written by my good friend Don Arbo. Thanks for that. And recently, I also wrote an implementation of the Flow language interpreter in Rust. So the test speed command will test your interpreter. And so let's say you pass in 100,000 integer with a value of 100,000. In both Rust and in Java, it'll take about a second to execute. It's a little bit faster in Java, but not a terribly big difference between the two. Your mileage will vary, of course, depending on what hardware you're running it on. Finally, let's take a look at the test Rust command. Now, the newbound command editor supports the writing of commands in Java, in Python, in Flow, and now also in Rust. And the way we implemented that support for the Rust language is where the story starts to get interesting. You see, in order to implement the Flow language in Rust, we needed to support all of the different types of operations. And operations include commands, and commands can be written in Java, Python, Flow, or Rust. So the Rust interpreter needed to be able to run Rust commands. And so we actually added the ability into the Flow repo. We have two binaries. We have the Flow binary, which is like Java or Python. It's how you would invoke code written in that language. But we also have the Flow B binary, which will basically take the data that was authored in newbound and generate actual Rust files from that and then compile them. So here in the newbound command editor, when I save my Rust code, it's actually running the Flow B binary in order to generate a Rust file, and then it's compiling that Rust file, and if there are any errors, it would tell you. So once your Rust code has been successfully saved, you can then go ahead and execute it. Let's go ahead and run our test cases here real quick. And you can see it got hung up on the test speed. That was significantly slower than normal. Usually it's closer to 1 second instead of 2. But nevertheless, you can see it successfully executed. Now, as I mentioned before, the newbound editor stores all of its data, all of the metadata that represents your application in the data folder. And the data folder is where libraries are stored, and inside of libraries you can have your controls and commands and all that good stuff. Now, the Rust interpretation, or the Rust interpreter for the Flow language, can also read the data folder directly, and so that is how source code is generated for Flow. If we go ahead here in the command line and we actually execute the test add command, you can see it performs the exact same function, just this is in the Rust interpreter. So looking forward, what I'd really like to do is port the commands. The vast majority of the Newbound development environment and runtime environment is actually written in Newbound itself in the form of these server-side commands. And what I'd like to do is rewrite all of those server-side commands that are currently in Java to rewrite those in Flow. And that would basically result in a version of the Newbound framework that runs natively in Flow, and the Flow can then be interpreted in any of the 4 languages. So you could run it in Java or in Python or on Node.js or natively through the Rust in the Rust interpreter. And then finally, what I'd like to do is add the ability to compile a Flow application into a native binary application that stands on its own. So no install necessary other than the binary for your platform. Now, the 2 main obstacles that I needed to overcome in order to successfully write a Flow language interpreter in Rust were, of course, the type safety inherent in the Rust language, and also the data, the memory management aspect of Rust, which is very strict in terms of instantiation of structures, etc. And so in order to be able to have an instance of an object existing in 2 different paths, flowing down 2 different sets of nodes at the same time, we needed to have objects or structures that could be accessed from multiple places, from multiple threads, and to make it super easy. Now, there are crates in Rust that address these types of issues. It certainly could have been done using 1 or more of them, but I really felt the need to write my own and do it the way I really feel that the Flow language needs to be accessible and to make it as simple as possible. So I went ahead and published the NData repo as a crate, and I think one of these days I will also go ahead and publish the Flow language repo as a crate as well. But it's not quite finished yet. There's a ways to go with this, and I don't think it's ready for cratehood just yet. And one of these days, I will get around to documenting both of these repos properly, I promise. In any case, that's a bit of a deep dive into the Flow programming language. I hope you enjoyed it, and we'll catch you next time. Cheers.